So I'm not going to do an introductory presentation to Bitcoin, since the vast majority of the audience is familiar with Bitcoin. And I thought I was going to talk about some interesting topics around this. First of all, I recently heard that Australia is considering taxing Bitcoin as an intangible asset with sales tax. Is that true?
As an asset class.
Yeah.
And so capital gains tax will be the implication.
Has this already happened?
I think it's very likely to happen. I think that's what we've been advised is going to happen.
So that is a monumentally stupid idea.
Yes.
As you can, that was my diplomatic way of speaking to politicians. It's as monumentally stupid as it would have been in 1994 to classify the internet as a fax machine service and put it under the control of the telecom companies, or to classify it as a CB radio, a fancy CB radio, and ask every user of the internet to pass a Morse code exam and get an operator's license. And those things didn't happen because at the time, the regulators took a wait-and-see approach and decided to let the technology itself flourish for a while before trying to apply any regulations. It's a good idea, because the truth is that very few people really understand what Bitcoin is exactly and how it works. And I don't mean very few politicians. I mean very few people in general really understand Bitcoin. I wouldn't count myself as one of them. I understand parts of Bitcoin, but I don't think I can predict where this thing is going. I don't think I can predict even a fraction of the types of applications that are likely to be built on Bitcoin. None of us know. This is uncharted territory. The reason it's uncharted territory is because nothing like Bitcoin has ever happened before. I don't say that, just as an extreme statement. I think it's absolutely true. The idea of a trusted, decentralized network that allows any individual anywhere in the world to transmit value or establish ownership over a digital asset and transmit that in a matter of seconds, anywhere in the world, transparently, safely, almost instantaneously, and for less than a third of a penny. That has never happened before. And we don't know what uses that will be put to yet. I can think of 1,000 different interesting uses, but we don't really know. It fundamentally changes some of the core assumptions of how money works. And the thing is that while we conceive of money as this universal thing, in fact, we experience it as many different aspects of money. There's fast money, there's slow money, there's money that works best in small increments and money that works best in large increments. I have some money that's printed on metal coins in my pocket, and that is fantastic money to use to pay a parking meter. If I try and go buy a Porsche with that form of money, I will need a wheelbarrow, and most likely they will look at me funny at the Porsche dealership, right? Or if I try to buy a house with that form of money. If I try to pay for the parking meter with a check or a bearer certificate bond, I will be looked at funny by the parking attendant. And when I try to get on a tram here, apparently I need a Mickey card. And I don't know what a Mickey card is, or Mikey card, and how to get it, and how to charge it. And I certainly don't know if I can use it for anything else. What I'm getting at is that we don't experience money as a universal protocol. We experience money as a series of fragmented networks, very fragmented networks. And there's a parallel to this. Before the internet age, telecommunications was like this. If you wanted to send a long-distance message, you'd write it down on paper and use the postal service. If you wanted to transmit video, you'd use a broadband connection to a satellite and bounce it off there. If you wanted to transmit text rapidly, you'd use a telegram or a telex. If you wanted to transmit an image, you'd use a fax machine. If you wanted to transmit video, well, you couldn't really. You could put it on a VHS tape and then mail it somewhere. So every type of content had a different network, and those networks were segregated by speed and convenience and cost and time to destination and all of these restrictions. And the internet brought all of these things together. It brought all of these things together and allowed us to use a single network, regardless of the type of message we were sending, and use it for fast and slow, for small and large, for cheap and expensive, right? And that was really an interesting thing because it suddenly changed the way we use information. It didn't just make it more convenient. It didn't just make it more accessible. It fundamentally changed the way we used information. Things that we would only do sparsely, we could do now continuously. Things that were too expensive to do were now cheap. Things that were too far to reach became close. We're about to do that with money. Bitcoin does that to money. In the financial environment, there are literally hundreds of different networks. There is SWIFT, the Society for Worldwide Interbank Fund Transfer. And you've never used SWIFT. Unless you're a broker, you've never used SWIFT. A SWIFT terminal is something a bank has, and they use it to send $25 million wire transfers to another bank somewhere else in the world, right? So that's the big payment-only bank-to-bank network. There's Visa, and you can use that. If you're a merchant, you can receive on it, and it's a consumer-to-business network. But it only works really above $5 approximately. It doesn't work for less than $5. And there's an upper limit, really, on what you can send. So if you want to send $25 million through Visa, you can't really do that. And you can use checks. And you can use ACH clearinghouse, the way we call it in the States, which is checking account clearinghouse for transactions between individuals. I don't know how easily you can send money from individual to individual here. If you want to, say, pay your rent. In the United States, most people write a check because that's the most convenient way to do it. They take money from a digital bank account. They write on a piece of paper. They put this paper into a terrestrial mail transport system where it takes 3 days to arrive at their landlord. Their landlord takes this piece of paper, presents it to the bank, which in itself is complicated. The bank then types something into a computer, and then the money is transferred, and then it sits there for 3 to 5 business days. This is in 2014, in the most prosperous country in the world. And this is no less than insanity, right? Now, I don't know if it's easier for you guys here. In the UK, it's somewhat easier to send money between 2 individuals in a bank. It's probably a bit easier for you. But if you wanted to send money from here to New Zealand, even though it's not that far, I bet things would suddenly get a lot more complicated. And you might have to revert to some kind of paper-based instrument. Or you might have to pay some third-party intermediary like Western Union $35 for the privilege of moving money across an ocean, as if they have to physically carry stacks of gold. Whereas in fact, what they're doing in the back end is no different than an email. We live in a world where banking is horribly fragmented, where finance as we experience it is broken. The experience for a consumer is different from that from a business. The experience for a small amount is different from a big amount. If you want to send money fast, you can only send small amounts. If you want to send large amounts and fast, you can't do that unless you pay a lot of money, and it gets really, really complicated as soon as you try to send money across borders. And then there's Bitcoin, a single network that can transmit anything from microtransactions, meaning you can send 1,000th of a penny, to gigatransactions, meaning you can send $100 billion. And the fee you will pay is the same, exactly the same, 1/3 of a penny, maybe. And the time it will take to transmit is the same. 5 seconds later, it's going to be visible across the entire global network. You'll get clearance in 10 minutes. And it doesn't care about borders, and it doesn't care about who the recipient is, and it doesn't care if the recipient is a consumer or a business. It doesn't care if the sender is a consumer or a business. if the device you're using to send it is a desktop, a mobile, or not. It doesn't care if you took the keys off a paper wallet, or if you typed a PIN into a wallet, or if you use your desktop computer. Bitcoin bridges all of those things and provides, for the first time, something that's never happened before, which is a unified protocol for transmitting value. Now, if you think about Bitcoin that way, it is as big a revolution in the affairs of finance as TCP/IP was in communication. It provides a single unified transmission protocol that spans any amount, any destination, and gives you a flat playing field that anyone can connect to. Now, to call that an intangible asset and stick GST on it as if you really understand exactly what that is hubris, at the very least. Short-sighted, probably, and grossly idiotic, most likely. We don't know where this network is going. But what we do know is that it has opened the possibility for creating hundreds, thousands of applications that we could never envision. And even the most wild-eyed optimists and visionaries amongst us really don't know where this is going. I was on the internet in 1989. At the time, it took days to send an email across the internet. You had to have Unix command line skills. It used an email protocol called UUCP store and forward, which was as clunky as it sounds. And if you asked me then, what will people be able to do with this network? I could imagine instantaneous email. I could imagine online shopping, eventually, as a far possibility. I certainly couldn't imagine Facebook or Twitter, and I most certainly could not imagine Bitcoin could pop out of this internet experience, but it did. And today, we look at Bitcoin as a protocol, and we have one app. It's a killer app. It's currency. And it's a currency without governments and banks, and it's something unique that's never been built before, but it's just the first app. And we have no idea what other apps will be created. Maybe one day, you'll be able to use Bitcoin instead of a Mickey or Mikey card. Maybe you'll be able to use the same payment network to pay for your tram, your parking meter, your Wi-Fi, and your hotel room, instead of having to juggle 5 different payment systems. I've found the experience of visiting Australia quite funny because as an American, I come here bearing 20th century technology. I have a credit card with no chip, which apparently is an alien artifact from a previous century, as far as most Australians are concerned. Because they'll take my card and they'll wave it over a reader, and nothing happens. It reminds me of this episode of, I think it was Star Trek, where they go back in time and they land on the planet and they go into a computer store, and one of the Star Trek crew picks up a mouse and goes, "Computer?" And yeah, that's my experience with my card. And every time I have to explain, no, this is an old style, swipe and sign. And they're like, wow. Swipe and sign, yeah. I'm like a time traveler to the future. It's amazing. That doesn't stop us, however, from sending our president here to tell you how to manage your Great Barrier Reef. It takes a certain level of audacity to go to another country, be completely oblivious about the fact that we have inferior technology in the big scheme of things, and then tell other people how to run their business. But we seem to be pretty good at that. So my experience with credit cards here has been rather revealing, because even within the world of credit cards, you see these vast differences. And every time I travel, the same problem keeps happening to me. I've called every single one of my banks, and I've told them in every different way that I can that I travel a lot. So I tried to explain to them that if you see my credit card pop up in Southeast Asia on Monday, in Australia on Tuesday, and in Kuala Lumpur on Wednesday, and Paris the next day, that is normal behavior for me. So do whatever you need to do to your fraud management algorithms. That is my normal. And so every time I go traveling, I'll swipe my card, and then I'll see on my email that I got a missed call on my US phone number from Visa Fraud Prevention Services asking me to verify that this was indeed a charge made on my account. And if I don't respond to that message in 3 days, my card gets shut down. So now I'm traveling the world with a piece of plastic that is literally worthless. And no matter how many times I've tried to explain this, there are notes on my account that say, don't shut down this card, this is normal behavior. They can't get their head around the possibility that someone would travel to different countries and interact with foreigners. So my credit cards are broken. But if you think about it, credit cards are broken by design. And most of us don't really think about how broken credit cards are. So let's go back and look at credit cards with clear eyes and examine all the ways in which they are broken. First of all, credit card technology was invented in the 50s. This technology started just after the Second World War. In 1950, I believe the first card was a diner's club card. And this was essentially a plastic version of a traveler's check that had your name on it and a member number, which at the time was a 4-digit number. And so this technology has now been extended into our current, always connected, internet-enabled, global, multipolar world. But it hasn't fundamentally changed, and that's why it's failing. It's failing at every level, because credit cards are broken by design. The most fundamental way in which a credit card is broken is the fact that every time I buy something with a merchant, what I'm giving them is the credentials to draw money from my account. So I'm giving them the secret keys to every merchant I interact with. And the more you use your card, the more you give your secret keys to every merchant. They then store them and build giant databases with 50 or 60 million of the secret access codes to everybody's credit accounts. And then they act with surprise and shock and dismay when a hacker comes along and steals all 60 million credit cards out of their super secret database. And there are two types of companies in this world. There are companies that have failed to protect their databases of credit cards and have been hacked. And there are companies that will fail to protect their databases and get hacked in the future. No one can stop this from happening. If you put everybody's access credentials in a single database, it will get stolen. Simple as that. People will always find a way. Credit cards are broken by design because every time you do a credit card transaction, what you're doing is you're opening a channel that allows that merchant or anyone who gets that information to do a pull request, to pull from your account. But credit cards are also broken by design in another very fundamental way, which is that the credit card information doesn't stand alone. It is connected to your identity. And in order to execute a transaction, you have to provide your identifying information. You have to provide a name. You have to provide an address. You have to provide additional information. In many cases, and in many countries, it's not uncommon to also provide a tax number or date of birth for almost every online commerce credit card transaction. So what that means is that now you're not just exposing the credentials that can pull from your account, you're also exposing elements of your identity. Elements that, when enough of them are collected, you are now a victim of identity theft. And so credit cards expose you both to theft and identity theft every time you use them. It's really difficult to see the comparison for people who don't understand Bitcoin and to understand that Bitcoin transactions have no identity on them by design. And that is not a problem, that is a feature. And that when you execute a Bitcoin transaction, the transaction itself gives the specific amount of value to the merchant and nothing else. And by having that transaction, they can't go back and charge your account again. They can't pull money from your account again, because you pushed a specific value to them. That's what you signed for. You can't forge that signature. So Bitcoin doesn't expose you to theft, and it doesn't expose you to identity theft, which means that when you operate with Bitcoin, all of the rules of the game change. If you've ever tried to build a merchant solution, an e-commerce solution, or you've tried to take credit cards, you'll notice that you have to do a lot of work to keep those cards secure. The moment you touch credit cards, every system that touches them has to be secured, firewalled, encrypted, audited, monitored, etc. And Bitcoin systems don't have to do that. I can add a Bitcoin payment system on my website, and every transaction I receive with Bitcoin, I don't have to encrypt it. It doesn't have to come over an encrypted connection. I can store it in a database. It doesn't have to be encrypted. It doesn't have to be monitored. If you go in there and you steal all of that information, you've managed to create a somewhat smaller replica of what's already on the blockchain. So what did you achieve? Nothing. You just got a small subset of Bitcoin transactions. You can look them up on the blockchain. You don't need to break into my website to get them. I can transmit those over an unencrypted medium. What this means is that you can do an incredible amount of innovation with Bitcoin that you couldn't do before, because you can leave the network open to access. And you can make the e-commerce channels completely open. For example, there's a company in the US that is using Chirp to do Bitcoin transactions. And Chirp is a protocol using sound. So essentially, your phone sings a little tune, almost like an old-style modem, in a frequency you can't quite hear. It's kind of like a buzzing sound. And a microphone in the merchant's store picks up that sound and gets the Bitcoin. Anybody else can pick up that sound too, but it doesn't matter because Bitcoin transactions are not sensitive. So you can transmit them in the open. You can write them on a poster. You can transmit them over unencrypted Wi-Fi, over unencrypted Bluetooth, low energy. You can use Chirp. You can use NFC. You can basically broadcast these transactions any way you like. You don't need to encrypt them. You don't need to protect them. That fundamentally changes the way we do payments networks, because all of that security goes away. But the most important thing that Bitcoin does in that context is it provides consumer protection. Bitcoin is consumer protection by design, because it doesn't force you to reveal your identity, and it doesn't expose your account credentials to merchants. Now, this seems hard to understand, because a lot of regulators want to regulate Bitcoin for the safety of the consumer. And quite honestly, the consumer is doing pretty fine with Bitcoin. We're safe. No Bitcoin merchant is going to get hacked and have 60 million Bitcoin accounts stolen, right? Consumer safety on Bitcoin comes from the design of the protocol and from two fundamental concepts. One, you remain firmly in control of your money at all times. And two, you don't reveal anything sensitive when you do a transaction. Those two things together make it the most secure payment network we've ever built. If you want to hack 60 million Bitcoin accounts, you have to hack 60 million devices. There's no one place where all these keys are stored. And if you want to protect consumers, the best way to do that is to leave them firmly in control of their own money. Now, a lot of the regulators, and I'm seeing this in Australia too, but we've certainly seen it in the US, believe that the best way to protect consumers is to add identity information to every transaction, and then have every Bitcoin transaction have every user identify themselves, and then provide that identifying information both to the merchant and to intermediaries, regulators, auditors, merchant processing companies. So what they're saying is, take your private identifying information and give it to the very same intermediaries who have been losing your private identity information for the last decade. That is not consumer protection. What that is incumbent protection. What that does is it protects banks from competition. It makes Bitcoin lose some of its most powerful features so that it is no longer a competitive threat for the banks. So when you hear politicians here in Australia or anywhere in the world talk about regulating Bitcoin, we have to ask ourselves, what are they trying to achieve? Are they trying to achieve consumer protection, or are they trying to achieve incumbent protection? Because if they're trying to achieve consumer protection, then they would encourage individual control over money that Bitcoin already offers by design. In fact, they would encourage Bitcoin because Bitcoin is the most exciting, disruptive innovation that is likely to inject competition into the banking industry that desperately, desperately needs competition. And if you create competition in the banking industry, that is good for consumers. So in the context of the regulations around GST in this country, I think it's important to realize that regulations like that are not just short-sighted. They're not just missing the point about what Bitcoin is. But they serve to hamper a new exciting innovation that has the very real possibility of competing against banks and disrupting their environment and giving them some competition that they desperately need. And by doing regulation in that way, Australians are not making Bitcoin slow down. What they're doing is making Bitcoin move out, right?